we are presenting on cowshed wastewater intended for indirect potable reuse. My name is Sabrina.
My name is Kendric.
I'm Chase, and Nadav is Azrieli counterpart.
So cowshed wastewater is water that has been used in an agricultural setting. This wastewater is specifically coming from the cattle or cattle produce industry. And this wastewater contains a high level of organic matter, salts, and nutrients. Indirect potable reuse wastewater is the reuse of a wastewater for the purpose of drinking, and specifically this wastewater has gone through an extra treatment, which is typically an environmental buffer. So this could be percolation through a wetland or sand filtration. And this indirect reuse reduces the import demand of potable water to an area because it typically keeps that water in a local aquifer. We analyzed a cowshed wastewater sample, and we found that the physical parameters, so turbidity and TSS, turbidity being the murkiness of the water, was 12.6 NTU. We found that by refracting a beam of light at 90 degrees through the sample and then measuring the amount of reflected light, typically turbidity should be around less than 0.5 NTU. We also measured the total suspended solids, which is in our case 551 milligrams per liter, and we found that by filtering a sample of this wastewater, drying that filter out, and then weighing the amount of solids within that filter. We also tested chemical parameters. So we tested for nutrients, pH, and chemical oxygen demand. The oxygen demand should be around 400 milligrams per liter. And we found that by putting it in a bottle and measuring the amount of oxygen used over a 5-day period. Ammonia was measured through a colorimetric test, and phosphates were measured through an ion chromatograph. pH was measured by finding the amount of hydrogen ions within the water sample. We also looked for biological parameters. Specifically, we looked for coliforms, which are typically present when there's fecal matter, which from a cowshed source, it is most likely going to be there. And we did that by, again, filtering a sample of this cowshed wastewater and then culturing that sample for at least 24 hours. And then after that was cultured, we were counting the amount of colonies of these coliforms, and these were above the detected limit.
Okay, so for treatment of the wastewater, we separated it into 6 different samples. The mixing device you see in the picture there controls the RPMs and the time that it's mixing. Each vessel has a different concentration of coagulant. The one on the left is the control with 0 milligrams, and then working up to the one on the right has 50 milligrams, and they all increase at the intervals that you can see in the chart at the bottom. Process, you have coagulation, which is a fast mixing where we put in iron chloride and you immediately start mixing it at 120 RPMs for 60 seconds. After this, you slow the speed to 15 RPMs for 15 minutes to create a relative velocity between the large and small particles so that they latch on to one another or flock to one another. Now you stop the spinning and you let them settle for another 15 minutes. The larger particles that flock to one another will sink to the bottom. We found that the best concentration was 20 milligrams per liter because it left the least amount of bacteria floating, and that's what you want, because if there's stuff floating in the middle of the beaker, as you can kind of see in the image here, on the one all the way to the right, then it doesn't filter out later on. And then finally, to disinfect the water, we use ozone, which is the blue liquid in the beakers in the picture on the bottom.
Now moving on to a cowshed wastewater application in Israel. The Kibbutz Sha'ar Makim is a dairy farm in Israel. It has about 350 cows and gets about 30 cubic meters a day. And how they obtain the wastewater is 3 main sources: the milking parlor, collecting yard, and rinsing water. And after they get it, they ship it off to a wetland where they do natural biological filter. And the objectives just to get it to that biological filter is just to get removal of solids, reduction of organic load, and rinsing water. Next slide, please. Now we can move on to a cowshed wastewater application in California. California is the largest dairy state, and 80% of the dairy farms are located in Central Valley. The dairy program that has been put in place implements strict measures to protect water quality, but also they monitor liquid and solid animal byproducts that could affect surface and groundwater quality from runoff. And these pollutants from runoff that they are trying to get fertilizers, nutrients, salts, pathogens, and sediment. Next slide, please. All right, so a potential reuse or treatment plan that we could use is just like the other applications that I just said, we can reuse it by via irrigation or watering crops, or even discharging the treated wastewater into a natural water source. And how we would do that is we would use a local wastewater treatment plant, such as the Point Loma one. And you can, again, either discharge it into a natural water source and it will then be treated later in a tertiary step, or it will be discharged into the ocean. Next slide, please. And we would like to give a special thanks to our sponsors, Curtis and Shirley Chambers, the Murray Gallinson San Diego Israel Initiative, and the Israel Institute. So thank you for the amazing experience.